Let's try this problem of finding the total area between y equals x squared and y equals 2x on the interval from -1 to 4. That interval is a closed interval. We are going to count all areas between the curves along that interval as positive. In this scenario, I want you to notice that between -1 and 4, the curves actually cross twice. That means we're going to have 3 distinct regions, one between -1 and 0, the other between 0 and 2, and the other between 2 and 4. So we're going to break this up into 3 distinct regions. Let me shade the actual area that I am calculating. I've went ahead and done that. So there's 3 areas that we're looking at. This purple area here, where the x squared is above y equals 2x. The green area is where y equals 2x is above y equals x squared. And I wrote this other area in as purple because, again, y equals x squared is above y equals 2x. There are the 3 distinct areas that we want to add up. From -1 to 0, x squared is on top. From 0 to 2, 2x is on top. And from 2 to 4, x squared is on top. That means we're going to have to create 3 integrals, 3 definite integrals, and calculate each. Let's do just that. My first integration is going to be from -1 up to 0. When you plug that in, remember the x squared was on top. So we're going to take x squared minus 2x and integrate with respect to x. That's that first region. The second region is going to go from 0 to 2. And in that region, the 2x is on top. And then a third region, which is going to go from 2 to 4. The x squared is back on top. When doing the integration, you can do this all on one line, or you can do the 3 integrations separately. I think for the sake of just looking at it, I'm going to do the 3 integrations separately. I'll call this area 1. I'll do that. And then I'll call this one area 2, and I'll call this one area 3. And then I'll add up the 3 areas. Let's go ahead and do this first one. This first one, when I take the antiderivative, I'm going to get 1/3 x to the third minus 2/2 times x squared plus any constant that I want. 2/2 is just 1, so I can leave that off. Going from -1 up to 0. Then I can plug in 0. This is a nice polynomial, so plugging in 0 gives me 0. Minus, what do I get when I plug in -1? I get a 1/3 times -1 to the third power minus -1 squared. When it's all said and done, 0 doesn't do anything, but I have a minus 1/3 times -1 to the third. That's a -1/3 minus a -1 squared. That gives me -1. I basically get minus -1 1/3 or -4/3. However you'd like to write that is fine. So the total area, since I have a negative of a negative, the total area is 4/3 for area 1. That leftmost area is 4/3. Let's take the second integration. I'll call the area we find here area 2. This is going to have a similar antiderivative, although it's going to be swapped in order. I'm going to take the x squared minus 1/3 x to the third as my antiderivative, going from 0 up to 2. When you plug in 2, I end up with 2 squared minus 1/3 times 2 to the 8th. When I plug in 0, I get 0. 2 squared minus 1/3. I'm sorry, I misspoke. That's 2 to the third. I looked up there, and that looked like an 8 instead of a 3 because my cursor was probably in the way. That's a 3. 1 minus 1/3 times 2 to the third. This also gives me 4/3, interestingly enough. Let's look at our last area or our last section. We'll call this one area 3. Antiderivative, we can use the same antiderivative that we used before because it's the same function that we used in area 1. So we can use the same antiderivative, 1/3 x to the third minus x squared. Just change the bounds. Now we're going to go from 2 to 4. Plug in 4. 1/3 times 4 to the third power minus 4 squared minus what happens when we plug in a 2. We've done this, something close to this plug-in. 1/3 times 2 to the third minus 2 squared. I'm going to type that in on my calculator in one big step, excuse me. I got 6 2/3, which as an improper fraction is 20/3. That means the total area is what I get when I take 4/3 and add up another 4/3 and add up a 20/3. 4 plus 4 plus 20 is 28. 28/3 is one way I can write the area. You can also approximate that by rounding it to a couple of decimals. Rounded to a couple of decimals, it's 9.33. So lots of different ways to write that. 28/3, 9 1/3, or rounding it would give you 9.33. So there you go. That's how we do problems like these. When we want to sum up areas in multiple regions, we just go ahead and set up each integral separately, and then calculate each one, add up all the areas. Again, sometimes it's easier to set them up separately and solve them separately because of just room on your paper as you're writing down.